Hi, my name is Tudor Girba, and I want to talk about moose. Who knows what moose is? Excellent. So I don't have to talk about moose. So then let's talk about what do you want to know about moose. I mean, I can go through my presentation, but we can also talk about what you want to say. Yeah.
Just tell us.
About what? So what do you, if you know about moose, what is moose? Anybody, just come on.
A bunch of tools for exploring.
Bunch of tools for exploring
It
code.
seems like there's a lot there.
Code, right?
Yeah.
Exploring code. So who agrees with that? Bunch of tools for exploring code. Excellent. Who does not agree?
Also.
Okay, kind of. Also. Okay, so another definition. Somebody else?
I think that's more about exploring the software or the program itself, more than the code. I think that the program is more than the code itself.
Like what is else in the code? In the code?
I don't know, you can, with Moose, I could model like an execution, I can...
So other kinds of software-related data. Anything else? So that's okay?
Let's say there's a bunch of engines to build tools to explore data.
Okay, so that's like engines with which you build tools, with which you actually go and do stuff, right? So it's true, it's kind of all of these things together, actually, right? So, and today I just want to go with you through some real life scenarios in which you use these tools. So how, in theory it looks like interesting and funny and colorful often, but the question here is, how is this useful? So where is the actual value? Where does the value come from? That's just what I would like to talk about.
For me, the value comes from being able to show to someone very fast some interesting property about a problem.
Right. But let's look at the real, so we'll just go and look at some real examples. So first, moose, right? So we said, well, moose is useful for all sorts of things. And what we say moose is that it's a platform for software and data analysis code purpose. Yeah, platform for software and data analysis. This is the quote. So if anybody asks me what moose is, repeat after me, platform for software and data analysis. Could you do it again?
Platform for software and data analysis.
Excellent. This is what moose is all about. Now,
like software and data, not data
software and data at the moment. So we have to take people slowly. Like 10 years ago, we were primarily about software, primarily about code. We're no longer about that. Now, and you've also talked about the idea of exposing stuff from existing data. And the goal, so this is the description of what it is, but what's the goal? What's the goal of this? What's the, if I say that's the goal to which we want to go, well, what is that? And we spend some time thinking about it, and at the end we come up with one single thing. The moose is all about making analysis easy. And the way it looks, right? It looks like this. You probably have seen screenshots in this way. So this is a Finder kind of thing. Here, in this case, I do have some classes. In this case, they are Java classes. And I'm looking at this class. And then I have here a query, give me all those that are annotated, and I have another class here. And then I can start visualizing the same classes and say, okay, where are these classes located in my system, right? I just flip a coin and then boom, I have that information. So all of a sudden here I have a query and I have visualization. And it's just very, very cheap. And then you can click something here and then you look at another visualization. I want to look inside one class if that's what I want to do. And at some other point here, you say, well, I want to look at the classes, but in a completely different way. In this case, it's 3D. And all of these things should be cheap, should be inexpensive, should be very, very quick to do. And, but we also talked about here about not just the tools on which you click, but also the tools with which you build the tools on which you click. And so here you have a little visualization, and this one isn't just that visualization, but what we basically spend most of our time on is making this code which produces the visualization fit in this screen. Okay, you notice there's no scroll bar here? That's the power of moose, the missing of the scroll bar. Right? So, and then this is for one visualization, this is raw cell, mostly done by object profile. And this is now, here you have a little browser, here I have a list of things, and then I'm visualizing it over there. And what's the script that does that? It's this. Do you notice the missing scroll bar? This is interactive here. This is not just that picture that Excel produced. It's interactive, these are all live objects. And so, we don't just stop at doing, visualizing things, we also take care of how to input things, right? So who knows here about petit parser? Right? So if you don't know, you should know. So this is a parser, so it's an engine that allows you to build parsers. And we don't just stop there because we want you to build parser files. This is our mission. And in order for you to do it, we provide you with a development environment, right, in which you can also debug things. So in this case, I have there is an SQL grammar, and then here in this table is matched by this particular production after I ran it. And then you take a look at it, and you have also a visual depiction of it. And we have all sorts of other things. Like here, I'm looking at all the models that I have loaded. And then I have a special browser that browses just the annotations of it. And they are all, again, we are using our own tools all the time in order to support our own development. So, now if we come back, what Moose is all about is crafting analysis made easy. That's the mission. Now what does easy mean? Now for me, easy means 15 minutes. That means I have a problem, I want to build a tool, it should take me 15 minutes to expose what I want to expose in that data. That's how long a tool building should cost. Now why 15 minutes? So how many here works in a, how many of you work in a team? Team of people, more than 4 or 5 people? Excellent. Now do you go to lunch together? Just think about it. How long does it take from the moment somebody says lunch until the moment you actually go to lunch? It's about 10-15 minutes. Now the thing here is that everybody has this budget. 10-15 minutes is already allocated. You don't have to ask for permission for anything. That's given to you. Now, I want to fill that space. And if we can make that space meaningful, not just fun, but meaningful, then we can change the way development works. And that's what we want to do with Moose. So, let me give you some real code, like some real situations in which this is actually possible. So how does it look like in practice? So the first one, I often deal with Java systems. And the first story I'm going to tell you about is, this is a system that is an enterprise system. It uses JBoss, and it's using JBoss 5 specifically. Any of you ever heard of JBoss 5? Okay, it doesn't matter. It's just version number 5 from JBoss. JBoss is an enterprise system. It's one of those things that lies on the server. It's a monstrous thing, and on top of it, you build these little things on top. And there, you have the beans that serve, stateless services that serve things to the outside world. And they are then all managed by this magic thing that is this JBoss stuff. And it's fantastic because you can deploy it, and it scales, and it's clustering, and everything in there. Except when you have little problems. And so we were having experienced this problem in a real system, deployed in a real environment, and the system had to be rebooted every week. And why is that? Well, memory leak, obviously, right? So the memory just boom, 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 increased, boom, 4 gigabytes, boom, reset. That was it. That was the only solution that we could find. And then we said, well, what's the problem there? Now, we didn't know what the problem was, so we started to dig into it, right? So then you just do memory dumps, and then we did experimentation, say, okay, let's try this thing here. And basically, you know how any of you have seen Enigma? Maybe right here in an Oxford-like thing. The movie Enigma?
Oh, yeah.
Yeah. Like when they were waiting for the convoy to be attacked by the Germans, right? In order to make the most of it, and we were doing the same. Like we were waiting for the memory to leak, right? In order to try our hypothesis. And then it took like 2 months to figure out where the problem came from. Now the problem came from one thing. It came from a little bug in JBoss that says that if you have 2 stateless services that point to one another at runtime, so if you have a cycle between those beats, and the pool is sized in a certain way, the memory allocation pool is sized in a certain way, you are prone to have a memory leak. Now, the specification allows those things. This is not an issue. But that particular JBoss bug basically was costing lots of zero figures Swiss francs. Right? So how do you approach this problem? Well, let's take a look at it. So the way it looks is like this, when you have public class A that implements an interface A, and there you have this annotation, and there is a private whatever that points to the interface. It's another class one that is annotated like this, points to this one, right? So it's like this, right? It's kind of a cycle, but it isn't. There's no cycle here, right? Because class A inherits from interface and points to the interface of this guy, and this one points to the interface of that guy. So statically, there is no cycle. But at runtime, there is a cycle. So, what do you do? What do we do to not have this problem happening again? Remember, we've already spent 2 months figuring it out. What would you do? Like, pretend you're engineers now. We need to engineer a system, and now we know where the problem comes from. What do we do?
Solve the problem.
Sorry?
Solve the problem.
Solve the problem. Is that all? So we go and take this cycle out somehow, and then it's fixed?
No, we need to put it in the continuous integration build as a test to see that
I
nobody
would
is
not
wrong.
consider myself as an engineer if I wouldn't, ensure that I don't do this thing again. Because, I've spent the 2 months. Now I should spend the rest of the 15 minutes and ensure that this never happens, right? And this should be a 15 minutes job, shouldn't it? Now, think about it, right? Do we really have a problem now? Do you really have a problem in this age of detecting cycles in graphs? Is that like an issue? I don't think so. So, but it's only, okay, maybe this is not quite a graph, but we could manufacture a graph, right? If we know this pattern, and we look at it as data, we should be able to build a graph, right? And that ability should be right there at our fingertips, because we're doing engineering stuff. And this is how it looks like in moves. This is the real code. Okay, so it simply says, give me all the classes that are not integrated remote, and then detect from those cycles to all. That's a bit of a magic in there, but it's not much magic. And then here it says, well, detect the cycles such that are implied by a relationship to all of those, and then here's a block given this class. Manufacturers basically collects all the attributes that are declared that gets a declared type, and then it considers all the subclasses of that type, and boom, this is how it considers the cycles. Okay? It needs a bit of time to get used to it, but that's the code. Do you notice the missing scroll bar? That's the code. It actually took about 10 minutes to do. And then it was, part of a report that maybe looks like this, and then it was integrated into continuous integration environment, and then it can never happen again. That is what a tool can do for you. Now let's take a look at another one. I just look here, I looked at Java code, right? Okay, so it's about code. But it doesn't have to be about code. Let me tell you about another one. It's the same system, it's still JBoss, and it still has these little issues. But in this case, it's a performance problem. Well, it's a performance problem, and it looked kind of like this, like the report came and says, yeah, the system is slow. When, by the way, whenever anybody tells you that the system is slow, don't believe them. They don't know what they're talking about. They should tell you, if I click here, it's slow. Then you believe them, then you start digging in, right? And then they told us, look, actually their problem was sometimes clicking here was slow, and sometimes clicking here was not slow. And we didn't really believe them at first, but then we had to believe them because, well, we saw it. And I was like, okay, what's going on there? How come that sometimes it's slow and sometimes it isn't slow? So then we started digging in and then said, okay, maybe it's a cache problem. Because, every time you have something like this, it can be a cache problem. And it turned out that indeed, in that particular scenario, there was some sort of caching involved. Now, the problem there is, well, how do you figure out a cache? Well, the only way you can figure out a cache is by looking at it in practice. Because the cache, by definition, depends on the way it is being used. I can't reason about a cache statically. This just doesn't work. So how do we do it? Well, the cool thing was that this system already had the logging system in place. And this is a real log file here. And in these gigs of logs, right, there were these nuggets, right, saying this is a cache hit. And then we said, wow, and this is a cache miss. Right? So that specific cache, that was really nice. The other thing we noticed is that actually there seemed to be like 2 different types of queries that were being sent to the cache. And so that was really nice because, and in fact, this is a printout of the actual transfer object that is like the object that was being sent to the request. And we got all this little, all the actual strings that are for the request. Now, armed with this one, it was really nice because, well, you know, okay, we couldn't really play with the real system because the real system was deployed and in Java, you know, we have no chance, it's off limits, boom, done. So you have to have, we had to copy the system locally, right? But we didn't just copy the system, right? We copied everything, the system, and the database, again, another one. And then we replayed, when we parsed these caches and hits and misses, and we had the timestamp, and we replayed against the temporary system. And then, when we replayed it, right, first of all, we have done the chart of the cache hits and cache misses on the production, right, from the production mode. Now, how did we test that our copy was indeed, and our simulation was indeed a replica of the production system?
Look at the logs of the production system and see if they're similar.
Right, we draw the same chart, and we put them on top of each other, and if we produce the same chart, then we said, well, it's representative, right? That was a simple thing. Remember, right, we had to go to build this chart first. That was a 15-minute job, because we just quickly put the chart in. But then it turns out, well, you know, so it seems like, okay, it goes 56, like a 59 average, but then it turned out that there were 2 parts of the cache used in the same place of the system after being without the beginning. And then when we split, you remember we had query and another query, okay? We split according to that in the same tool, quickly, boom, reproduce the chart on the subsets. And then we noticed, well, actually, we didn't, this one was rather poor, 50% cache hit, this is not good. But we didn't really care because it was not affecting a large part of the system. This we cared about. And look at it, like it's like, now it's 50, now it's 100, now it's 40, now it's 100, now it's 20. This is all over the place. This is like worse than roulette, right? Because like, it's worse than not having the cache because, you know, a cache that is unpredictable, right? I mean, if people expect slow, then it's fine, or not fine, but it's better than just having it up and down. Because they just get their expectations up and then boom, you fail. So, then we said, well, we have to fix, we have to do it here. And then we knew precisely where to look because we had the name of the class. And then we look at it, and it took 2 hours to find the problem. The problem was that by mistake, people were mapping on these, you know, magic strings were not properly aligned. And they were we were basically dropping the cache every 15 minutes. So that was the problem. So, and then we fixed it, right? And how did we test that we fixed it? Well, we did the chart, right? We used the same requests. Now that we know that our copy is representative for the production, we could use the same request, and then we applied it again on the same system, and we have that. And now we knew that when we will deploy it on the real system, and now the customer was expecting a real solution, right? Because it was already under pressure. Now we knew that we can deliver, and we had a very good probability for it. Now the round trip, everything you have seen here, from the problem, from not knowing anything, to actually having absolutely the final solution committed in the code, took about 2.5 man-days, approximately. The key in all this thing was that we could have put a shape on the data. And then we could dig in quickly. This super fast loop of hypothesis, looking at the data, hypothesis looking at the data. This is not code, is it? Now, so this is how it actually looks like. It looked like in that thing, and in that thing. This is the very, 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 very original version of the expected that you will see this afternoon. Now, I showed you now Java, right? This is Java system. But I happen, for example, to develop in Smalltalk for quite a bit of my time. And I'm also using it in order to solve my problems. Now, how does it look like? How does this look like in a Smalltalk environment? Well, let me tell you this story. We're having, anybody heard of Glamour? Okay, so Glamour is an engine for building browsers. And the cool thing about it is that you can, just script things and very quickly in a very compact manner, and then you have these workflows around, and you have to, browsers are being kind of generated for you, and you don't have to deal with the MVC and stuff like that. So it's pretty cool, but we had a problem. We had a little bug, and Glamour is prototype based. That means that every time you click something, then the whole thing gets copied, and it does magic stuff in there. Now, the thing is, when you do prototype-based, everything looks the same. So when you have a problem and you need to debug it, all those objects, they look absolutely the same, because everything is in the ID. That's where the key is. So the debugger is pretty much useless. The default debugger is useless for debugging those kinds of problems. So we had this little problem that it seemed like in some situations the UI wasn't refreshed properly. In fact, it was copying itself kind of oddly. And it took about half a year, with about 4 people investing effort in it, continuously. And we just could not figure out where the problem was. We couldn't even write the test. Huh? That was the funny stuff. Like after half a year, we wrote the test, but we could still not figure out how to fix it. So it was just laying there for about 2 months, this test, and they wanted us like, hey, you're not eating your own dog food. So then we stepped back and said, well, how does it work? What kind of information do I really need? And then I said, well, let's put a face on it. And then I said, well, I took, about 2 hours it took to build this. And this is done with Grossout. So what you're looking at here is a structure of a browser. So you have the panes here, and you have the transmission, and the ports, and everything that links between them. And that's the structure of the browser. Now, those things are being related to the rendering objects. These are the rendering objects, right? And you notice the only thing we need to care about here is that an object on the browser structure is being rendered by a rendering object, right? And now one thing I knew, right, I didn't know where the problem came from, but one thing I knew was that there should be no two red edges going here. You notice here? 1, 2, problem. That, by using this tool and trying with a couple of browsers, and I noticed that basically depending on the level, right, the deeper it went, the more edges got accumulated there. In the end, basically, it took about half an hour to find the one line that I needed to copy, to fix. I fixed it, the bug was fixed. And how did I know the bug was fixed? I put a shape on it, right? And then I looked at it, and I was like this. Now this is not even about objects. This is really about debugging. I constructed a very, very specific debugger for my little tiny problem. Not doing it costed a long time and lots of effort. Doing it changed the problem upside down. Now let's take a look at a slightly different kind of problem. And here's this thing. So I have here I have these problems. We were developing the inspector, and at some point we had this. We're using Rubric. Rubric is a new text editor for Pharo. And here you have a rubric more that is being inspected that has this a little text in it. Our problem was we couldn't really understand exactly how the shout, so the text highlighting was kicking in. But we didn't really understand where that thing was. In fact, we could find the class, this shout decorator, it was there. We could find it, we could see it in the code, but there was no references to it. It's like, what the heck? Is this actually being used, or is we're just looking at the wrong thing? So then we said, well, wait, I can inspect this object. Now if I can inspect this object and I look at the structure of this object, and I will traverse everything that this object touches, and I will display it in the chart, maybe I can see if I get what I want. So that's what I did. I switched then to the state, and I wrote this code here. Notice the missing scroll bar? So what this code here does, it traverses deeply all the instance variables here, and gets only the instance variables that start with the rule, because that's the prefix for those classes that I'm actually interested in. And then, based on that, it builds a little chart. If I execute this, I got this graph over here. And you notice here, shop styler decorator is actually being referenced at runtime by this editing area. And the way this happens is actually, obviously, you know, if you don't have a direct reference, obviously there's reflection happening. Some sort of reflection. And that's how I knew, okay, I was in the right place, let's dig a bit deeper, and then we found it. But the round trip was really, really fast. And this is not about debugging, this is about code. It's slightly, okay, actually it is about code, but it's slightly, you know, looking at it from the object's point. All of a sudden, it's not the same thing. Now, sometimes you want to put a shape on data, not to solve a problem, but to start a conversation. Sometimes you want to communicate that what I do here is important, is real, because people don't see what we do, right? And that was the case when we have released Pharo 3. When we released Pharo 3, we want to show the world we are doing a ton of stuff. It's not just that boring list over there. And that's why we got this. This is based on Code City. And in fact, people start talking about the picture long before they start talking about Pharo. And the goal here is to start a conversation. Now, the interesting thing, we're using all of those things, everything you've seen today, is done with one single coherent set of tools. That probably takes a couple of days to get into. Now, the question here is, why is this relevant? Now, given that we are here close to London, anybody here knows what this is? This is a picture of the staff of the London Underground from 1939, digging through 4 million tickets to figure out how to optimize the London Underground. Now you might find this a bit ridiculous, but I have a question for you. I have here 250,000 lines of code there, right? If I do this, is it different? Is this how I want to deal with this data? Is this the best we can do with this data? I think not. Could you pay attention to the... Right? I'm paging down right now. It doesn't work like this. There is much more to software engineering that we have paid attention to, I believe. And we should first of all understand that we are not dealing with text. And by the way, here you're just looking at text data. Because people say that when they develop systems, they read code, which is actually not true, because what most of the time I have seen in enterprise systems is people read logs. At least we produce this. The logs were produced by the machine. We cannot scale. This is not a tiny problem, this is a huge problem. And it starts with the realization that software isn't text, it's data. And data can be beautiful. Now for this one, you need technology. It's not enough technology, but it's necessary. That's what Moose is here for, to start that conversation. Thank you very much. Do we leave it at that and we move the conversation to the lunch area, or?